I'm afraid that the visually interesting part of the evening is over. If you saw this little, I call it a prologue, that was running as you came in with those images, all of those represent sort of players or motifs in the subject of my book and the subject that I'm going to be talking about tonight. Ranging from bats to monkeys to chimpanzees to dead horses, hazmat suits, containment units, chickens, air travel, wrecked forests, bats. Did I say bats? More bats, still more bats, and at least one very menacing duck. Those are the players in the subject, along with the one missing player, of course, which is human beings. Those images can all be united under one word, and the word is the subject of my book. The word is a slightly technical word, but it's one that's going to become part of the vernacular. The word is zoonosis. Zoonosis. A zoonosis is easily defined as an animal infection that's transmissible to humans. And if the infection causes disease, once it gets into humans, then it's a zoonotic disease. There are some animal infections, viruses, bacteria, fungi, other pathogens that can be transmitted from non-human animals into humans, and they don't necessarily cause disease. They become innocent passenger infections. There's one that I especially love because it has a gruesome name, and that's something called Simian Foamy Virus. Simian Foamy Virus, isn't that vivid? It doesn't cause simians to foam. It doesn't cause humans to foam when it gets into humans. It causes cells under a microscope to expand and sort of bubble in a foamy-like way. And it passes from macaques, like those two that you saw hugging, into humans in Southeast Asia. But as far as we know, it doesn't cause any disease. Some scientists call it the virus in search of a disease. But many of these things do cause disease when they spill from a non-human animal into a human. And in fact, 60% of the known human infectious diseases fall into this category. They are zoonoses. They are zoonotic diseases in the strict sense. 60%. And that includes a lot of the famous old scourges. Bubonic plague is a zoonotic disease. Killed a third of Europe in the 14th century. Yellow fever, typhus, rabies. These are all old, familiar zoonotic diseases. So the phenomenon has been around for a long time. But there are also a lot of infamous new diseases that fall into this category, zoonotic diseases. And the list ranges from Ebola and Marburg, West Nile fever, and I know people in Texas know about West Nile fever, Lyme disease, hantavirus pulmonary syndrome, bird flu, swine flu, and AIDS. AIDS itself is a disease of zoonotic origin. And I tell the story at some length in my book. The penultimate chapter, the crescendo, is about the origins of the AIDS pandemic. And I can tell you, I can't even begin to summarize it because it's a sad, complicated, tragic, of course, but scientifically intricate and fascinating story. I can tell you that we now know, based on work published in the last 5 or 6 years, that the pandemic strain of HIV, the one that accounts for most of the cases of acquired immune deficiency around the world, passed from a single chimpanzee into a single human in the southeastern corner of Cameroon in Central Africa around 1908, give or take a margin of error, early 20th century. And I think that for most of us, that's much different from the conventionally understood story of the origins and spread of the AIDS pandemic. But as I say, that's a long, complicated story. and I probably won't go into it tonight. There's a still longer list of these zoonotic diseases that are obscure and yet scary, in some cases of small significance in terms of numbers, but large significance in terms of illustrating the principles, things that most people have never heard of. Machupo virus, sometimes known as Bolivian hemorrhagic fever, Kaisener forest disease, Hunin, Lassa from Africa, Crimean Congo hemorrhagic fever. There's a nice name too. Crimean Congo hemorrhagic fever, Australian bat lyssavirus, Nipah encephalitis, Hendra virus disease. These are things that fill the pages of my book and fill the lives of the disease scientists who study this phenomenon, this type of disease, but they haven't gotten much attention outside of the immediate regions that they've affected. A number of them come from Asia, and this subject returns to Asia time and again, and as I was researching this book over the course of 6 years, I returned to Asia time and again. I'll talk a little bit more about the specific Asian connections as I get into this. But first, this one that I mentioned, Hendra virus. Hendra is a textbook case of this phenomenon. Hendra virus was discovered in 1994 in eastern Australia, actually a suburb of Brisbane, Australia, by the name of Hendra. It's a horse racing suburb. It's filled with stables, racetracks, jockeys, horse trainers. And in September of 1994, horses in one particular stable suddenly started getting very sick. Their faces swelled up. They ran fevers. They became clumsy. They had trouble breathing. They were falling down. Bloody froth was coming up their windpipes. And 3 men tried to take care of these horses, a veterinarian, a horse trainer, and a stable hand. The horse trainer, the man who ran the stables, got very sick as he was trying to take care of these horses. These horses were dying one after another. 7 of them died in 12 hours, which is a huge amount of horse death, even if you're a hardened veterinarian. So these 3 guys were trying to take care of these horses as they died. And then one of the fellows, the horse trainer, got sick and went into the hospital. Another fellow, the stable hand, got very sick and he went home to suffer through it. They both felt like they had a really bad case of the flu. The veterinarian stayed healthy. They had all been up to their shoulders in this bloody froth coming out of these horses. And then the horse trainer died. They isolated a virus from a sample from, I believe it was his kidney, liver or kidney, and they found a virus. It was a new virus, a virus they'd never seen before, but they could say that it came from a particular virus family, the paramyxoviruses, which also includes measles. So roughly all they could say was that it was a measles-like virus. They looked in the dead horses. They took samples, blood and tissue from the horses that had been necropsied out in a street in front of this stable. There was blood running down the gutters. It was a gruesome scene. They sampled the horses and they found a virus there, the same virus. The same exact virus is in the human. So they knew this then was a case of spillover, a pathogen passing from a non-human animal into a human. Now, great thing about zoonotic diseases, dare I say, of course they're not great. They're horrible. And there's a lot of suffering and a lot of death in this book. But from the perspective of the writer or the reader, one of the redeeming things about this gruesome subject is that every emerging disease starts with a mystery story. It starts with detective work. So after they had gotten to this point with this new disease, this new virus in the horses and the humans of Hendra, Australia, they went looking for the source because they knew it couldn't be a virus that lives perennially in horses. It had suddenly caused all these horses to be grotesquely ill. It had to live somewhere else. And in the parlance of zoonotic disease, the somewhere else the place in which a virus or another pathogen lives permanently, chronically, inconspicuously, without causing symptoms, that is called the reservoir host. The reservoir host. An animal, a kind of animal, a species of animal in which a virus or another pathogen lives over the long term inconspicuously without causing disease. So they went looking for the reservoir host of Hendra. And they took samples from all of the animals that were around the stables and around the pastures where the horses had been pastured. They looked in kangaroos and wombats and wallabies and rats and birds. They even looked in insects, biting flies, and they didn't find a virus. And then finally they looked in bats. They looked in a particular species of fruit bat that's common in eastern Australia, a big thing belonging to the genus Pteropus, also known as flying foxes. You saw some of them in my little prologue. And they found the virus in these flying foxes. They found it at 3 or 4 different species of flying foxes, all native to eastern, northeastern, and northern Australia. So then they knew that these flying foxes, these giant fruit bats, are the reservoir host of Hendra virus. They continued their detective work. They wanted to figure out how it had spilled over. And they put a scenario together. They realized that the very first horse that got sick had been a pregnant mare who was out in a pasture outside of the suburb of Hendra. She had been put out there to rest up to the point of delivering her foal. She had been the first one to get very, very sick with these same symptoms: swollen face, fevers, clumsiness, bloody froth. So the trainer had brought her in from that remote paddock to his stables, and she had been the first to die. And then it had been and they didn't know why she had died. They thought maybe she'd gotten bit by a snake or eaten some weedy, toxic weeds out in that pasture. But they realized in retrospect that she must have picked this up. The veterinarian, when I went, the veterinarian was still alive. He had never gotten sick. And when I went to research this, he took me out to that pasture, which is now a housing development. And he showed me, this is the place where that first horse got sick. And it was no longer a pasture. It was ticky-tack houses up and down these little streets. And there was one that was a circle. They called it Calliope Circuit. And in the middle of that little circle was a patch of green grass. And on the green grass was a single tree. And the tree was a fig tree, a native Moreton Bay fig of Australia. And the veterinarian looked at it, and he hadn't been back there since this housing development had been built. And he pointed at it and he said, "That's it. That's the bloody tree." And he meant that's where the bats had roosted, and that's where the horse had grazed, in the shade of the tree. And that first horse had evidently grazed in the shade of that tree. The bats had roosted there. They had dropped fig pulp after they had chewed on it. The fig pulp had their saliva. The saliva had this virus. They also dropped their feces and their urine on the grass. The horse grazed all this up. She got very sick. She infected the others. That was the first spillover of Hendra virus. And so they had succeeded in doing the detective work. The detective in that case was a veterinarian named Hume Field. Now, having told you that story, I want to pause just a second and say that essentially I have 3 goals this evening. I want to give you some idea of the basic dynamics of zoonotic diseases, and I've already been doing that. Spillover is the moment when it passes from a non-human animal into a human. The reservoir host is where the virus or the other pathogen hides over the long term. An amplifier host is an important concept. The horses, in this case, at least from the point of view of humans, were amplifier hosts. The virus got from the reservoir host into horses. It replicated abundantly. It went crazy, went wild in the horses. It thrived in the environment of the horse body, and the horses spewed out virus, and that infected humans. No human in Australia is known ever to have gotten sick with Hendra virus except from a horse, never directly from a bat. So the horses play this role of amplifying the virus. Of course, if you're a horse, from your perspective, you're not an amplifier host. You're a victim. But from our perspective, they're amplifier hosts. So that's the basic mechanics, dynamics of this phenomenon. Anyway, 3 goals. That's my first, to give you a sense of those. The second is to give you some idea of how this whole subject plays out in Asia. And I'll get to that, as I say. And my third main purpose is to give you a sense, encourage you to take away an understanding that these different events that I've been mentioning, the first outbreak of Ebola, the first outbreak of Hendra, spillovers of these other diseases, Hendra Virus in Yosemite this past summer, West Nile in the Dallas area, the AIDS pandemic, Sars, all of these things, they're not independent events that are simply happening to us. They represent parts of a pattern. And that pattern reflects things that we humans are doing. I'll come to that, back to that. Actually, I do have a fourth, I confess, I do have a fourth purpose tonight too. And that is to persuade you that this book that I've written is not as gruesome and serious and dire and dour as it may sound. I mean, it is all those things. And I said that it's filled with dying people and suffering and stories of disease outbreaks. But it's also filled with detective stories. It's filled with mystery. It's filled with suspense. I hope it's a page-turning experience. I hope it's a guilty pleasure and not an onerous duty, this particular book. It's filled with great characters, heroic scientists out there in the field, as Fritz mentioned, doing this work on the front lines, doing some amazing science. It's filled with little mysteries and solutions, and I hope even maybe a bit of humor. It's not a really funny book, but I hope, and I probably wouldn't say this if we were on C-SPAN right now, because things get taken out of context. It's not a really funny book, but I hope it might be the funniest book about Ebola you'll ever read. So, Asia. I want to tell you a few more stories, a few more case histories. In September of 1998, people started getting sick in peninsular Malaysia. And the symptoms included fever, severe headache, again, some clumsiness, some confusion. One victim had a hand that was twitching uncontrollably and eventually leading toward severe neurological problems, encephalitis, and in a number of cases, death. The health authorities in Malaysia at first thought it was a disease called Japanese encephalitis, which is caused by a virus that's carried by mosquitoes from pigs to humans and can cause these kinds of symptoms, can be very nasty. And by the way, when a mosquito or some other kind of an insect or an arthropod carries a disease from one human to another or from an animal to a human, that critter is called a vector. It's another one of the sort of terms, the pieces of lingo, of vector. So a disease like malaria that's generally carried by mosquitoes from human to human is a vector-borne disease. That doesn't make it a zoonotic disease. The fact it's in mosquitoes between humans does not make it fall into the zoonotic category. But there are some zoonotic diseases that are also vector-carried, vector-borne diseases. Lyme disease, carried by ticks from white-footed mice to humans, is a vector-borne zoonotic disease. So in Malaysia, they thought, well, maybe this is this vector-borne zoonotic disease, Japanese encephalitis. But the epidemiology didn't look right, because Japanese encephalitis, carried by mosquitoes, tends to differentially affect children. Children are less able to defend themselves against mosquitoes, or less aware of the importance of doing it, and they get bit a lot. And so a lot of the victims of Japanese encephalitis are children. Now, at the beginning of this outbreak, there were 2 young girls that died, and that's probably part of what started them thinking it was Japanese encephalitis. But then there were no more children. There were no more children. There were adults. And the adults were mostly male. And the male adults were mostly ethnic Chinese. They started asking themselves, well, what kind of a mosquito bites only adult male ethnic Chinese? So they concluded that probably that's not it. It's not Japanese encephalitis. They isolated a virus from one man. He came from a village called Nipah, N-I-P-A-H. They looked at this virus and they said, my gosh, it's a new virus, but it's also a paramyxovirus. It's like that one in Australia. It's very closely related to that one in Australia, as a matter of fact, but it's distinct. They named it Nipah after the little village, and then they started on the detective story. In the meantime, they had pigs that were coughing and barking and wheezing all over the country. Not so many dying, but clearly they had something. They were passing something from one pig to another on these big piggeries, these big pig farms in peninsular Malaysia, some with thousands of pigs confined in pens out in the open. And this disease was spreading from one pig to another, even from one pig farm to another. One fellow told me that they called it the 1 mile barking cough because you could hear this disease coming from the pig farm over the hill and know that soon it would be in your pig farm. So they looked at the pigs, they took some samples, and they found the virus, the same virus, the virus that they had named Nipah, the virus that was killing ethnic Chinese. And then they realized which ethnic Chinese men it had been killing. It had been killing pig farmers and abattoir workers and pork handlers and pork sellers, anybody involved in the pig industry. So they realized then that this is a zoonotic disease that seemed to be passed directly from pigs into the people who closely worked with pigs, pig farmers. Eventually 109 people died before they controlled this outbreak, and they controlled it by culling 1.1 million pigs. They essentially eliminated industrial-scale pig farming in peninsular Malaysia. But then there was still the detective story. Where had this begun? They went looking for the virus again in all the candidate species that might be the reservoir host. And because it resembled the virus Hendra from Australia, they said, well, let's look at bats. Let's look at giant fruit bats. They looked at giant fruit bats. The fellow that I mentioned, Hume Field, who had been the disease detective in Australia, they said to him, please come up and help us in Malaysia. He went up there and said, let's look at the bats. They looked at the bats. They found the virus. So they knew, and it was a different species of bat, but the same kind, the same genus, Pteropus, giant fruit bat, flying foxes, but the ones that are native to the Malaysian peninsula. So then they started putting some more of the detective story together, and they realized that a couple of things had happened. Humans had done a couple of things. Had cut down much of the native forest in peninsular Malaysia, clearing it for agriculture, for human sprawl, for timber, for other reasons. And in doing that, they had destroyed the bats' natural habitat. These bats eat fruit, they eat blossoms, they drink nectar. Usually they would do that in the wild forest, the wild hardwood forests of peninsular Malaysia. But those were largely gone. So the bats were displaced, they were desperate, they were looking for food. The pig farms, many of them, contained fruit trees. The farmers had planted mango trees and water apple trees around their piggeries, in some cases shading their pigsties. So they realized, again, it was like the horse in the pasture in Australia. The pigs came to these no flying pigs in this particular story. The bats came to these fruit trees. They ate the fruit pulp, they ate the mango, the water apple, they dropped the pulp. It fell into the pigsties. So did their feces, so did their urine, so did all this virus from them. The pigs ate everything that fell, and they got very sick with this virus. In most cases, they didn't die, but they amplified the virus. The virus replicated abundantly in the body of the pigs, and the pigs shed a lot of virus, so the pigs were the ideal amplifier host for this virus to infect humans. And when it got into humans, its case fatality rate was about 60 to 70%. Extremely lethal, right up there with Ebola. So this was the case in Malaysia. I'm going to touch very briefly on what happened then in Bangladesh a couple of years later. That outbreak in Malaysia was the last one, essentially, late 98, early 99, and Malaysia made changes, and there has been no outbreak of Nipah virus in Malaysia since then. But it has been outbreaking in Bangladesh, neighboring country, about every year or two since 2001, and killing people, killing several dozen people each year in January or February in Bangladesh. Well, Bangladesh is a much more orthodox Muslim country than Malaysia is. There are very few pigs in Bangladesh. So how was this disease getting transmitted into humans? The same fruit bats were there carrying the same virus, and they eventually figured out that in this case it was passing from fruit bats into date palm sap, which humans drink fresh, and then into humans. In January and February of each year, there's a tradition in Bangladesh of tapping certain species of date palm tree for its sweet, syrupy sap, like tapping maple syrup. So people climb up into the tree and they cut a slash through the bark and they put a little clay pot underneath the slash, and the sap drips into the pot. They climb down, they leave it there overnight. They come back in the morning, they climb up, they get that pot, they bring down fresh date palm sap, and they sell it to people on the street corner. People come out with a glass, they buy a little bit, and they drink it right down. Great, except the bats were pooping in it. The bats were coming to these slashes. They were licking the sap as it leaked out. They were attracted to it just the way humans were. And they were defecating and urinating and sometimes falling dead in these little clay pots. Not very appetizing, but people love this. And Bangladeshi people told me, some fellows I went into the field with said, yeah, I used to drink that when I was young. It's great. You got to get it fresh. If you cook it, it's no good. You got to drink it fresh. If you cook it, you kill the virus, but if you drink it fresh, then you get the full flavor and you get the full strength of the virus. This fellow told me, I don't drink it anymore since I've been working on this project. Anyway, so that's how this disease happens in Bangladesh, because people have this tradition of tapping the date palms. The other main case that I investigated in Asia, well, there were several, but SARS. SARS is a very important and very interesting one. 2003, SARS emerged from southern China, probably having, well, we know in retrospect, I'm not going to tell the mystery story in its mysterious order. I'll short-circuit it in this case, but SARS also has its reservoir host in bats, at least one species of bat in southern China. It got from bats into other forms of wildlife, probably in the big live markets where they gather wildlife of all different species to sell for food. There is a, as you may know better than I do, there is a fashion in southern China. I think it's called Ye Wei, wild flavor. And the fashion says that it's very invigorating, it's very healthful, it's very robust to eat wild animals. This is not a subsistence thing like in Central Africa. This is an affluent consumer fashion, as I understand it. So, so there are these big markets. In these big markets, some of them, bats are piled up in cages with masked palm civets and other creatures, and some of those creatures, porcupines and bamboo rats, get sent to restaurants where people butcher them. And somebody got exposed to this virus. It caught on, it moved from southern China to Hong Kong, and from Hong Kong it got into a single hotel, formerly known as the Metropole Hotel, where it infected people along one corridor, and then those people got up and got on their planes and flew home from their Hong Kong vacation to Toronto, Hanoi, Beijing, Singapore, and they were sick. They were infected. There was a 78-year-old grandmother who flew to Toronto and infected her son. She died. The son died. People at the hospital where the son had been treated got sick. Some of them died. Eventually, about 8,000 people were infected with SARS. About 900 died, which is better than 10%, which is not as severe as Nipah, but it's really, really a high case fatality rate for something that's transmissible the way SARS is, which is through the respiratory route, on a sneeze, on a cough, like influenza. I'm gonna read a little section, about 2 pages, about SARS, because I want to give you a little bit of the flavor of this book. As I said, I hope it's not just a pile of information. It's also, I hope, an act of storytelling. And the best way I can give you a sense of how this particular zoonosis got going is with this little passage. There was the first man infected, or known to be infected in southern China, was a wholesale seafood merchant named Mr. Zhu Zuofeng. And I say this: no one seems to know where Mr. Zhu picked up his infection, though presumably it wasn't from seafood. Fish and marine crustaceans have never been implicated among the possible reservoirs for the pathogen causing SARS. It is a virus, by the way. Zhu ran a shop in a major fish market, and possibly his sphere of activities intersected with other live markets, including those that offered domestic and wild birds and mammals. Whatever its source, the infection took hold, went to his lungs, caused coughing and fever, and drove him to seek help at a Guangzhou hospital on January 30th, 2003. Guangzhou, of course, is the big city in the province of southern province of Guangdong, just across from Hong Kong. He remained at that hospital only 2 days, during which he infected at least 30 healthcare workers. His condition worsening, he was transferred to a second hospital, a place that specialized in handling cases of atypical pneumonia. And that's what this was being called. When a doctor doesn't know why you're suffering a lung infection, he or she calls it an atypical pneumonia. That was the only label they had at that point. 2 more doctors, 2 nurses, and an ambulance driver were infected during the transfer of this Mr. Zhu to the second hospital, as he gasped for breath, vomited, and spattered phlegm around the ambulance. At the second hospital, he was intubated to save him from suffocating. That is, a flexible tube was inserted deep into his mouth, past his glottis, and down his windpipe into his lungs to help with breathing. This event represents another important clue toward explaining how SARS spread so effectively through hospitals around the world. And one of the hallmarks of SARS was that a lot of healthcare workers were infected. Intubation. It's a simple procedure, at least in theory, but it can be difficult to execute amid the gag reflexes, sputters, and expectorations of the patient. The task was especially hard with Mr. Zhu, a portly man, sedated and feverish, and though his disease hadn't yet been identified, the attending doctors and nurses seemed to have had some sense of the danger to which they were being exposed. They knew by then that this atypical pneumonia, this whatever, was more transmissible and more lethal than pneumonias of the common sort. Each time they began to insert the tube, according to an account by Thomas Abraham, a veteran foreign correspondent based in Hong Kong, each time there was an eruption of bloody mucus. Abraham continues. It splashed on the floor, the equipment, and the faces and gowns of the medical staff. They knew the mucus was highly infectious, and in the normal course of things, they would have cleaned themselves up as quickly as possible. But with a critically ill patient kicking and heaving around, a tube half inserted into his windpipe, and mucus and blood spurting out, there was no way any of them could leave. That's Abraham. At that hospital, 23 doctors and nurses became infected from Zhu, plus 18 other patients and their relatives. 19 members of his own family also got sick. Zhu himself would eventually become known among medical staff in Guangzhou as the Poison King. I don't know how to say that in Mandarin, but I suspect it's vivid. The Poison King. He survived the illness, though many people who caught it from him directly or indirectly down a long chain of contacts did not survive. One of those secondary cases was a 64-year-old physician named Liu Jianlun. a professor of nephrology at the teaching hospital where Zhu had first been treated. Professor Liu began feeling flu-like symptoms on February 15th, 2 weeks after his exposure to Zhu, and then he seemed to get better, well enough, he thought, to follow through on his plans to attend his nephew's wedding in Hong Kong. He and his wife took the 3-hour bus ride from Guangzhou on February 21st, crossed the border, spent an evening with family, and then checked into a large mid-range hotel called the Metropole, favored by businessmen and tourists in the Kowloon district of Hong Kong. They were given room 911, across from the elevators in the middle of a long corridor, a fact that became central to later epidemiological investigations. 2 fateful things happened that night at the Metropole Hotel. The professor's condition worsened, and at some point, he seems to have sneezed or coughed, or, depending on which account you believed, vomited in the 9th floor corridor. In any case, he shed a sizable dose of the pathogen that was making him sick, the virus, enough to infect at least 16 other guests and a visitor to the hotel. Professor Liu thereby became the second known super spreader. That's another term in this field, another piece of the lingo. The Poison King was the first super spreader, and this professor became the second known super spreader of the epidemic. Among the hotel guests sharing floor 9 was a 78-year-old grandmother from Canada. I mentioned her earlier. She'd come to visit family and then spent several nights at the Metropole along with her husband as part of an airline hotel package. Her room was 904, just across the corridor and a few steps down from Professor Liu's. Her stay overlapped with his presence for only one night, the night of February 21st, 2003. Maybe they shared a ride on the elevator. Maybe they passed in the hallway. Maybe they never laid eyes on each other. No one knows, not even the epidemiologists. What's known is that the next day, the professor awoke feeling too sick to attend any wedding and instead checked himself into the nearest hospital. He would die on March 4th. One day after Professor Liu left the Metropole, the Canadian grandmother left too, having finished her Hong Kong visit. Infected, but not yet symptomatic, and presumably feeling fine, she boarded her flight home to Toronto, taking Sars global. That's the end of the little section here on that. And that's almost the end of what I want to say. I don't want to rattle on too long, but I will add that I talked about the underlying drivers of this pattern of more and more of these diseases emerging from wildlife into humans. The essence of what I say in the book about that is that there are 2 main categories of factor: disruption and connectivity. Disruption is we humans, all 7 billion of us, intruding more and more forcefully into the last great wild ecosystems of the planet, the forests of Central Africa, of the Amazon, of Borneo, Southeast Asia, and elsewhere, and the other highly diverse ecosystems where lots and lots of species of animals, plants, bacteria, fungi live. And in those animal, plants, bacteria, fungi, and other creatures live many, 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 many viruses. We're intruding more and more into those places. We're shaking the trees, knocking them down. We're killing and eating the animals. We're capturing the animals and transporting them around the world for medical research. We're dislodging viruses from their internal ecosystems within their reservoir hosts. We're freeing them like exotic species, like invasive species, to pass into new hosts where they don't have competitors and predators at the microbial level. Species such as us, we're making ourselves highly and abundantly available, all 7 billion of us. That's the disruption side. And then there's the connectivity. We pick up these diseases, and then, like the Poison King, we get on a bus and go to a big city. or like the 78-year-old grandmother, we get on a plane and fly to a different continent. The connectivity is the globalization of disease. And those two categories of factor, disruption and connectivity, at least according to the experts that I've listened to carefully for the last 6 years, are the factors driving this toward being a more and more severe, more and more menacing, less and less avoidable problem, the problem of zoonotic diseases. It's not a story without hope, without cheerful elements, without encouragement, because I write about the amazing scientists who are studying this phenomenon. And as the Sars story shows, these things, as dangerous as they are, as fast-moving as they are, can be stopped. Because SARS didn't die out. SARS was stopped by very good, fast diagnostic science, figured out what kind of a virus it was, categorized it, isolated it, identified it, had a sense of how to deal with it, and then very good, strong medical science and public health measures so that it was contained in Toronto, in Hanoi, in Beijing, in Singapore, before it could kill 9 million people instead of 900 people. So we've got this great science on the one hand, the fact that humans are very smart and very adaptable. And on the other hand, we have these viruses that are emerging from animals and getting into us. And they're not very smart, but they are also very, very adaptable. And what's going to happen? What is the next big one going to look like? Is it going to look like SARS, or is it going to look like AIDS? Well, it's impossible to predict and hard to guess. And I'll end by quoting you the last 3 words of my book, and that is simply, it all depends. So thank you very much.